Hello everyone, today we'll discuss a medium hard level dynamic programming problem, LeetCode algorithm problem 63, unique path 2. This problem is a follow-up problem from previous 62 unique paths, and the difference between these two problems is in this new problem, there is one more requirement. This one. An obstacle and the space are marked as 1 or 0 respectively in grid. A path that the robot takes cannot include any square that is an obstacle, which means if the value of the obstacle matrix is 1, then there's one obstacle and then the robot cannot pass. Otherwise, the robot can pass through. Okay, let's see. As we discussed before in the previous problem, there will be 4 cases in this dynamic programming problem. The first one is a special case, which is the first cell. And then the second one is the cells of the first row. And then the third case is also a special case, which is the cells of the first column. And then the last case is the common case, which indicates other cells except for the previous 3 cases. And we will see the cases one by one. Firstly, let's calculate the number of rows and the number of columns in the obstacle grid matrix. So if we get the length of the matrix, then we will get the number of rows. And if we get the length of the first row of this matrix, then we will know the number of rows in the matrix. This one is a typical pattern for problems with matrix. And in this problem, we will use the given obstacle grid matrix to store our dynamic programming matrix. So we can save a lot of space and dramatically reduce our space capacity. And okay, let's see. We will see in the first case. So we have 4 cases. The first one is the first cell here. If the obstacle matrix has value as 1, which means there is one obstacle blocking the robot, so there would never be valid path to the destination. So if the value of this matrix for the first cell is 1, then we need to return 0 because there will be no path. Otherwise, we will set it as 1 for the special case. And then we need to consider the cells for the first column. Okay, let's see. So for the first column, the robot can only go down and down and down for the one direction. So if the value of the obstacle matrix is 1, which means there is an obstacle here, so there will no longer be valid path through this cell. So for our dynamic programming matrix, this value should set to 0. And otherwise, if there's no obstacle, then the current value for the dynamic programming matrix needs to be the same as the up block, because uh, because the robot can only go down from the up block. So if the up block has 0 pass, then the current one is also 0. If the up block has 1 pass, then the current cell has 1 pass as well. So it will be the same as the number of pass going through the up cell. So for the up cell, it will be obstacle grid matrix I minus 1 and 0. Because we've already changed this before, so actually this value is current dynamic programming results for this cell. Okay, let's see the third case, the first row. From the first row, the situation is similar for the first column. So if the obstacle matrix equals 1, which means there's obstacle, so for our dynamic programming matrix, the value needs to be 0 because there will be no path due to the obstacle. And then if current obstacle matrix has a value as 0, which means there's no obstacle, so the number of paths will be the same as the previous cell, which is the left cell here. And the number of paths going to the left cell is was already changed before. So now this value is just the result for our dynamic programming matrix, but not indicates whether there's an obstacle for the left cell, because it's already changed before. And then the last one is the common case. So we will consider the cells except for the first 3 cases. So as we discussed before, in LeetCode number 62 unique paths, we have this basic pattern for the last case. So it's like the current value of the current cell is the sum of the value of the up cell and the left cell, because the robot can only go down from the up cell and go right from the left cell. However, because we have new requirement obstacle here, so we need to consider the current value of the obstacle matrix. If the value of the obstacle matrix is 0 in original, which means there is no obstacle, so our value for the dynamic programming matrix needs to be the sum of the value of the left cell and the up cell. Here, this one is the up cell and this one is the left cell, because I is the number of the rows, so I minus 1 indicates the up cell of the current cell, and J indicates the number of rows, so J minus 1 indicates this one is the left cell. And then if the original value of the obstacle matrix is 1, which means there's 1 obstacle, so we will set the dynamic programming matrix value as 0, because there's no path can go through this obstacle. Okay, in this way, we finished discussing the 4 cases, and after this, we will return the dynamic programming matrix value for the destination cell, so which will be in the obstacle grade m-1, n-1. By this way, we will solve this problem. Okay, let's submit our solution. And we can say it's success. So yeah, we finished this problem, and we discussed the time and space complexity. Because we use the space of the given obstacle grid matrix to store our dynamic programming matrix results, so our space complexity is only O1. And because we need to traverse the entire matrix, so the time complexity is O m times n. M is the number of rows, and n is the number of the columns. Okay, that's all for today. Thank you so much. Bye bye.